Hello there, everybody. This video is about 45, 45, 90 right triangles and how you find missing, excuse me, how you find missing sides in a 45, 45, 90 right triangle. And 45, 45, 90 is one kind of special right triangle. We'll talk about two of them. There will be a separate video for the other one. This one's about 45, 45, 90s. So how do you find those missing sides? Well, here we've got a special right triangle. It's a 45, 45, 90. We know that this side is 1. And again, we want to be able to find these other two sides. Well, a 45, 45, 90 right triangle, it has two equal angles. So that means the sides that are opposite those angles have to be the same too. And that's something we've done in the past. And it's true here as well. So if this side is 1, that means this side has to be 1 as well. And that will always be the case in 45, 45, 90s. The legs, not the hypotenuse, but the other two sides will always be the same. In this case, they're both 1. Now, we got to find a way to figure out that side. Well, we already know one way to do it. Pythagorean theorem certainly works. Here's the 90-degree angle. That side's the hypotenuse, so it's C. So we could do 1 squared plus 1 squared equals x squared. 1 squared is 1. So we get 2 equals x squared. And x equals the square root of 2. And that'll work. That'll work for this one. Now there are easier ways and there are shortcuts, and that's kind of the goal, is to help you figure out what these shortcuts are. So let's try to find a little bit easier way to do this, to figure out these shortcuts. So here's another triangle, another 45, 45, 90, and this side is 6. Now we said any 45, 45, 90 has two equal sides. And it's the sides that are next to the 90-degree angle. It's not the hypotenuse. However you're going to remember it is fine. So if this side is 6, that means this side is 6 also. And we need to find that. Now, will Pythagorean theorem work? Yes. But there is an easier way. These two triangles are similar. And any two 45, 45, 90s are similar. But any 45, 45, 90 is going to be similar to this one. So that means we can set up a proportion to find a missing side. So 6 goes with 1, so we could say that this is 6. We could make a ratio, 6 over 1. And then we want to find y. I put this triangle on top. So I'm going to put this triangle on top here. And y goes with the square root of 2. So y over the square root of 2. Now we can cross multiply and solve. Y times 1 is y. And then we've got 6 times the square root of 2. That is a little bit easier than doing Pythagorean theorem. Now again, there are shortcuts. If you see a shortcut, please use it. Well, let's take a look at this next one. Here, let's try to find this one. Now, this is a 45, 45, 90, so we know we've got two equal sides. However, the equal sides are the ones we don't know. So those are both x. So let's set up a proportion to find those sides. Now we know this one is similar to this triangle. So let's start with root 2. Root 2 goes with root 10. Those are both the hypotenuse. So we'll put root 2 over root 10 equals 1 over x. 1 over x. There's our proportion. Let's cross multiply. So we've got the square root of 2 times x equals the square root of 10 times 1, the square root of 10. Now you divide both sides by the square root of 2 because we want to get x by itself. And we get x equals, now root 10 divided by root 2 is root 5. And there we go. So all you really got to do is understand that 45, 45, 90s are always similar to this triangle. So you can set up a proportion to find any missing sides that you want. that helps. If not, get some help in class. See ya, bye.